Hi Pre-Cal students. We are looking at the last lesson of this unit, the solving trig equations unit. So what we're looking at specifically solving more double angle equations. So we looked at double angle equations a couple lessons ago, and we were looking at using the identities to solve. But not every equation can be solved using identity. For example, look at this first one, sine 2x equals 1/2. I know the identity for sine 2x is 2 sine x cosine x. So if I say this equals 1/2, now if I try to isolate the sine x cosine x, I'm going to multiply both sides times 1/2 to get rid of the 2 here. So my 2 and the 1/2 just kind of cancel out. And now I'm left with sine x cosine x equals 1/4. But I can't factor this, I can't use the zero product property, I'm kind of stuck here. Okay, so I got to try something different. So what we're going to do is we're going to look at 2x, kind of think of 2x as being our angle here. All right, we're going to solve for 2x. Theta is equal to 2x. And then at the end we'll take care of that. All right, but that adds a little wrinkle to what we're starting with. Notice here it says solve for all x's between 0 and 2 pi. 0 less than or equal to x less than or equal to 2 pi. Well, if I want 2x in here, I need to multiply this whole line by 2. So 2 times 0 is still 2. And then 2 times x is 2x. And then 2 times 2 pi is 4 pi. So what I need to get, if I'm thinking about 2x is what I'm solving for, I need to get all the answers between 0 and 4 pi instead of just between 0 and 2 pi. And you'll see why that is, hopefully, at the end. Okay? So I'm just multiplying what I have times 2, 0 less than or equal to 2x less than or equal to 4 pi. All right. So if that's the case, then I'm kind of looking at this as sine of theta. You know, instead of sine of 2x, my 2x is now equal to theta. Sine theta equals 1/2. Okay? So where does sine equal 1/2? Well, in the first quadrant, it's positive. And so my theta in the first quadrant 1/2, that's going to be pi 6. And then sine is also positive in the second quadrant, so that would give me 5 pi 6. And so that would be all the solutions between 0 and 2 pi, but I need to go between 0 and 4 pi. So I would also have pi 6 plus a full circle plus 2 pi, and 5 pi 6 plus a full circle plus 2 pi here. Okay? So let's simplify that a little bit. This pi 6 is fine, 5 pi 6 is fine. But pi 6 plus 2 pi, well 2 pi in terms of, if I'm thinking the common denominator is 6, that's going to be 12 pi 6. And so I've got 12 pi 6 plus another pi 6, that's 13 pi 6. Same thing here, my 2 pi is 12 pi 6, 12 and 5 is 17 pi 6. Okay, so this is between 2 pi and 4 pi, this is between 2 pi and 4 pi. In fact, they're both between 2 pi and 3 pi actually. All right, and my theta here, I'm just going to change it back to 2x. Okay, so 2x is equal to these. Now I want to get x by itself, so I'm going to multiply both sides here times 1/2. So I'm going to do 1/2 times pi 6, 1/2 times 5 pi 6 times 13 pi 6 and 17 pi 6. And that'll give me all my x values. Pi 6 times 1/2 is pi 12ths. 5 pi 6 times 1/2, 5 pi 12ths. 13 pi 12ths. Notice that now is between 0 and 2 pi. 17 pi 12ths. And that also will be between 0 and 2 pi. So those are 4 good answers that I'm getting from sine of 2x is equal to 1/2. Alrighty? Okay, let's look at the next one. Sine 2x is equal to 0. Alright, once again, I need to find 0 less than or equal to 2x less than or equal to 4 pi to get 2x here. So if I do that, if I think of that, sine theta is equal to 0. So where does sine equal 0? Well, sine would equal to 0 at 0, at pi, at 2 pi, and then going on to 4 pi, 3 pi, and 4 pi, right? Okay, so 2x is equal to 0, pi, 2 pi, 3 pi, and 4 pi. And then, once again, I'm going to multiply everything times 1/2 to get rid of the 2 in front of the x. And my answers are 0. 0 times 1/2 is still 0. Pi times 1/2 is pi halves. 2 pi times 1/2 is pi. 3 pi halves. And 2 pi. So all of those would be good solutions for this one. All right. And this one, actually, we could have solved it using the identity. We could have said 2 sine x cosine x equals 0 and solved it. In fact, we did that back on N14-3 if you want to go back and look at it. We did solve this exact same equation 2 lessons ago. Okay? All right, number 3. Sine x cosine x equals -1/2. So I can see that this is similar to my double angle identity for sine. Remember, sine 2x is equal to 2 sine x cosine x. Because the form it's in now I can't really do much with. But I can say, all right, if I have a 2 in front of this, I can change it to a double angle. So what I can do is I can say, all right, 1/2 times 2 sine x cosine x. And that's exactly the same, notice, that's exactly the same as sine x cosine x, right? Because 1/2 times 2 is 1 equals -1/2. Now this part right here becomes sine 2x. And so I have 1/2 sine 2x equals -1/2. So let's get rid of the 1/2 here by multiplying times 2 on both sides. 1/2 times 2 cancels. I've got sine 2x equals -1/2 times 2 is -1. Alright, so sine of 2x is equal to -1. So where does sine equal -1? Well, sine equals -1 at 3 pi halves. And then it would also equal -1. I need to go from, once again, I got to get 2x, I got to go all the way up to 4 pi, so I need 2 circles worth. So 3 pi halves plus another full circle, so that's going to be 7 pi halves. 3 pi halves and 7 pi halves. So get rid of the 2x, I'm going to multiply times 1/2. I'll multiply times 1/2 on these. X is equal to 3 pi fourths or 7 pi fourths. And those would both be good solutions there. All right, let me pull this up just a little bit. Sine of x over 2 equals √3 over 2. So we're going to kind of do the same thing, but notice this time it's x over 2 instead of 2x. So this isn't a double angle, this is a half angle. And I can kind of think, the same way. X is between 0 and 2 pi. Well, if I multiply this whole line times 1/2 to get x over 2, because that's what I'm solving for here is x over 2, 0 is still 0, and we'll have x over 2, but 2 pi times 1/2 is pi, so I only need solutions between 0 and pi. And so looking at this, sine of x over 2, so this is going to be my x over 2 equals √3 over 2, that's going to be at pi thirds and at 2 pi thirds in the second quadrant. Those are the only 2 places. Both of those are between 0 and pi. And now to get rid of the x halves, I'm going to multiply both sides by 2. And my answers should be pi thirds times 2 is 2 pi thirds, and 2 pi thirds times 2 is 4 pi thirds. Okay, last problem. Cosine of 2x is equal to sine x. Okay, on this particular one, I can't just solve it for cosine 2x. I can't use the double angle method we've been using for these other problems. So instead I'm going to use the identity. And remember, for cosine 2x, I have choices. I have 3 choices. I've got cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. And since that one has just sine squared, that's what I'm going to use. 1 minus 2 sine squared x equals sine x. Now I'm going to bring everything over to the right. So this will be a positive 2 sine squared x. This is a plus sine x. And this will be a minus 1. And this will factor, I think. I hope it does. It's going to be 1 times 1. They add to a positive 1. So I think it's a plus 1 like that. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. Just to save a little space, I'm going to do these two steps in one. I'm going to add 1, divide by 2, sine x equals 1/2, or sine x equals -1. All right, sine x equals 1/2. Well, then x would be equal to pi 6, or 5 pi 6. So there's two solutions there. Sine x equals -1. X must be equal to 3 pi halves. And there we go. We've got three good solutions. Okay? I know I went through that pretty quick. I hope it makes sense to you. Practice it. Let me know if you have questions. Later on in the week, I will be posting a review over these 5 lessons. We'll do a quiz following week. Okay? Bye-bye.